How do non-deterministic environments affect RL agents? Imagine you're playing a game where every move you make might lead to a different outcome each time, even if you do the same thing. That's what non-deterministic environments are like for reinforcement learning agents. These environments are unpredictable because the results of actions are not always fixed. When an agent takes an action in a certain state, the next state, and the reward it gets can change due to randomness or uncertainty. This makes learning a lot more interesting and challenging. In these settings, the agent can't just memorize what to do in each situation. Instead, it has to learn how likely certain outcomes are. It needs to understand that the same move might sometimes lead to a good result and other times not so much. This means the agent has to estimate probabilities of different results, which is often modeled as a Markov decision process with stochastic or random transitions. The agent learns to make decisions based on what is most likely to give the best overall rewards, even if outcomes aren't guaranteed every time. Because outcomes are uncertain, the agent faces a tricky balance between exploring new actions and exploiting what it already knows. If it explores too much, it might waste time on unlikely outcomes. If it exploits too early, it might miss better options. The agent needs to gather enough information about the environment's randomness to make smarter choices. This exploration helps it understand the distribution of possible results and avoid being fooled by random fluctuations. The policies that the agent develops must be resilient to variability. Instead of memorizing specific sequences of actions, it learns strategies that work well on average. This way, it can handle different situations and unpredictable changes in the environment. To do this efficiently, agents often build or approximate models of how the environment works. These models help predict likely outcomes and guide exploration toward uncertain areas that need more information. Some reinforcement learning algorithms are better suited for non-deterministic environments. Value-based methods like Qlearning estimate the expected rewards for actions, considering the randomness in outcomes. Policy gradient methods directly optimize the decision-making policy by considering the probability distribution of results. Both approaches help the agent learn to act effectively despite the unpredictability. In real-world applications like robotics, game playing, or AI assistants, environments are rarely perfectly predictable. For example, a robot navigating a busy street faces unpredictable obstacles, and a game player encounters random moves from opponents. Reinforcement learning agents trained in these uncertain settings learn to adapt and make decisions that work well even when things don't go as planned. Understanding how non-deterministic environments influence reinforcement learning helps us see why this type of learning is so powerful for tackling real-world problems. It also raises important ethical questions about designing agents that can handle uncertainty responsibly, avoiding harmful or biased decisions when outcomes are not guaranteed. In essence, non-deterministic environments push reinforcement learning agents to develop policies that maximize expected rewards across many possible outcomes. They must carefully balance exploration and exploitation and become robust to variability. This makes reinforcement learning a key approach for many AI systems that operate in the unpredictable world around us.